This one is just the second part of the last video. The velocity graph is given, and we need to find, as we saw in the last video, the particle first moves in the positive direction or in the direction to the right from origin, and then the velocity starts decreasing here at 0.6 second. At point C, the particle reverses direction and then starts coming back to the origin. So the question is when it returns to the origin. Now, so we have to look at the displacements. Now this shape, if I draw it here with a different color, this part, this is not an analytical there is no analytical expression given for this, so we need to find what we need to find the displacement is we need to integrate it. So we actually need to find the area under this curve, and since we don't have an analytical expression for this one, the velocity, we can use Simpson's rule to do that, because we have this value here for 2 seconds, this is 1, at 0 this is 0, and at 4 this is 5. So if we apply the 3 value Simpson rule, it will be like that, h, and of course h here will be 2, and then the first segment is 0, then this one is at 2, this one is 1, but this is 4 times the middle one, so 1 plus the last one which is at 4, and that is 5 here, so 5. So that's the area using Simpson's rule. So it is an approximation, but that's what we can get, and h is of course 2, so it's just applying the Simpson's rule, three value Simpson's rule. So 2/3 here, 4 plus 5 is 9, so that's 6 feet there, since the velocity is in feet per second. So up to here it goes 6 feet in the positive direction. So after t is equal to 4 seconds, this is 6 feet. T is equal to 4 seconds, it has gone 6 feet in the positive direction from origin. Now from 4 to 5, this is a triangle, very obvious triangle. This one is a triangle there, and we can find the area, because integration is area under the curve, so we are just trying to find the areas here. So this one will be half, have to use a dark color, yellow doesn't show up, half times this one is just 1 and then 5, so half 1 5 is 2.5. so for the next 1 second it goes another 2.5, so it is at 8.5 feet far at t is equal to 5 seconds. After that it returns, the velocity changes, so it will start coming back. So when we look at this graph from C to D, this is again coming at the velocity direction changes, but it's going at the same velocity and towards the negative direction. So from C to D, that is for the next 1 second, this one is 5 seconds, so for the next 1 second it will go here, which is this point is t is equal to 6 seconds, it will go just another 2.5 seconds, so the same distance it will go, 2.5 seconds, because it's the same triangle. So here it has recovered that 2.5 second, 2.5 feet, sorry. So our question is, after that the velocity becomes a constant 5 feet per second. That's the velocity. So what happens is it will come back to the origin. The question is, after how much time will it come back? So the distance it has to travel is, it has already traveled 2.5 feet back, so it has to travel another 6 feet, because from origin it is still 6 feet away. This distance is still 6 feet, because that's the 6 feet here, that is the 6 feet here. So this much distance, what it was here, the distance, that it will have to recover. So 6 feet with the velocity of 5 feet per second it will take, if we do the time. So this is the distance divided by velocity is giving the time is 1.2 second. So it will take another 1.2 second to return to the origin. So it has traveled already 6 feet, 6 second for 6 second now. So 6 second plus 1.2 seconds. So after 7.2 second it will return to the origin, because 6 second it has already traveled. Another 1.2 second later it will return to the origin. So actually what will happen after, say somewhere here 7.2, this full area, this area will be equal to this full area, so the positive area, so the total travel distance will be 0. That's the thing. And yeah, that's about it actually. So basically for this particle or whatever, this one has traveled in the positive direction for the first 5 seconds, and then it has returned to its starting point by traveling another uh, how much, 2.2 second. So up to this much, from here to here, 2.2 second this one. So for this 1 second it has traveled at this velocity there, and then it has taken a constant velocity and it returns to the origin at that velocity. So yeah, I won't make this any longer because that's about it.